an article, PISA, China tops, India has fled the race. Now, why did India flee the race? Well, maybe the testing wasn't suited to India, but maybe it was a little embarrassing that India only outperformed one other country out of 74, and that was Kyrgyzstan. Where is the courage? Is there going to be courage in India to fundamentally fix the huge problems that your country is in dire need of fixing? Mathematics is the platform upon which all of the solutions of India's problems in the future are going to be built. So whether it's science, technology, engineering or medicine, it's mathematics which is going to help India overcome its problems and enter in a new golden age of prosperity and spirituality and happiness. As you can see, the title of my talk is about the death of arithmetic. Arithmetic has been around for a very, very long time, but I noticed it has some major problems in its foundations a long time ago. So I've been working on fixing the foundations of mathematics since 1983, which is a very long time to be exploring a subject that nobody else even seemed to have really noticed. So anyway, I'm just going to go through the slides reasonably quickly, so don't worry about taking notes. You'll be able to download all of these slides later on. So from the death of arithmetic to the maths of divine India. So, India, we have a problem. Many hate or fear your maths. So, what happened? India and China used to lead the world in mathematics and be the world's leading economies. And if you look here, I've got a chart of GDP, global GDP, basically over the last 2,000 years. And if you look at the green line, you can see that India, around about the year 1, had around about a third of the world's GDP, which is absolutely remarkable. And I'm sure that very few people in India realise that you used to be such an economic superpower. You can also see in the year 1 that China was also an economic superpower. But as you can see in the chart with the green line for India and the sort of the grey line for China, both of the countries that were leading the world in mathematics went into a long decline. And as you can see here, China has begun to pick up dramatically and India has begun to increase, but not as rapidly as China. Now, these are some of the issues. I'm going to be sharing maybe some painful truths in a country that invented our mathematics system. And the painful truth is that Indian students have ranked second last in a global test out of 74 countries. So something's happening here, and I suspect that somehow maybe the Indian people, maybe like myself, intuitively didn't connect with Western mathematics. So maybe the reason India is underperforming is you know the mathematics is not right in your heart. And here's the statistics. This is from a PISA mathematics survey, which is a program for international student assessment. So in Tamil Nadu and Himachal Pradesh, 15% and 12% of students are ready to use their mathematics in ways that are considered fundamental for their future development. That's a very low share, when the OECD average is 75%. So you can see that when it comes to international comparisons of mathematics, these are the official statistics, and these two states were chosen by the Indian government. So imagine if they chose states that maybe weren't quite so good at mathematics, what those results might have been. Similarly, in the PISA science survey, in Tamil Nadu and Himachal Pradesh, only 16% and 11% of students are proficient in science to participate actively in life situations related to science and technology. The OECD average is 82%. So what I'm going to do is explore maybe how this came to be. And as you can see here, there's an article, PISA, China tops, India has fled the race. Now, why did India flee the race? Well, maybe the testing wasn't suited to India, but maybe it was a little embarrassing that India only outperformed one other country out of 74, and that was Kyrgyzstan. So if I wanted to study mathematics, I could go to Kyrgyzstan and maybe do as well as if I studied it in India, which is totally wrong. So we know that India once was a superpower in mathematics and a superpower in science, as was China, and I think what we have to do is to turn this trend around in a very big way. So this presentation talks about some of my notes on my mission to rebuild elementary mathematics from zero. So here I am sitting in the front row, and I noticed my teacher's explanation of maths was missing India's zero. And you can see that was 1968. And so I thought I'll have to fix this. So there I am, grade 2, 1968, age 7, was when I first started to get curious, or maybe it was when I first started to get confused about mathematics, if I'm to be honest. Fast forward to 1988, and here's an article where I'm quoted in the newspaper as saying, I hope to change the way the Western world teaches maths. So this was my project I began on the 18th of March, 1983, at around about 1 p.m. So here we are, various newspaper reports about my attempt to bring together all of the pieces of the puzzle of mathematics and make sense of it. And this paper here, the first peer-reviewed paper I had published, was based on my experience as a boy in class 2 at age 7. And what I didn't know when I was 7 was that I had stumbled across the fact that Euclid's definition of multiplication was incorrectly translated, and people have been explaining mathematics incorrectly because of a bad translation since February 1570. It's mind-blowing stuff that teachers all around the world will often say multiplication is repeated addition, and they'll say that that's Euclid's definition, but it's actually a man called Henry who put in his definition instead of Euclid's. So I'm now starting to move away a little bit from the research, and I'm now starting to tour India. This is my 3rd tour of India. On this occasion, I'm visiting 6 states. So here I am with students, and here I am in another class with 550 students. And the teachers, as it happens, are also asking questions as if they were learning mathematics for the first time. And this one was just from last week. Again, this is a group of Year 7 students. So the media has started to pick up on my research and my life devotion to restoring Indian mathematics, as you can see. You are probably in a better position to understand these newspaper articles than I am. Luckily, there is one in English. The others are in Hindi and Bangla. So, it's better to know nothing than to know what ain't so. That was Josh Billings, 1874, an American humorist. Now, in this talk, I'm going to be talking about arithmetic, the basic operations, plus, minus, multiply, and divide on the integers. So I'm talking about elementary mathematics. No rocket science here. Now, obviously, India's ancient integer logic got to us today, but how? What facts do we know? So I'm just going to review quickly the accepted history of mathematics, just in a few minutes. So India's definition of zero as a number and integer arithmetic was embraced by the Arabic world, and you might know that in the West they're often called Hindu-Arabic numerals. So the Arabic world was instrumental in the passage of Indian arithmetic. Al-Khwarizmi wrote a book on Hindu integer arithmetic which featured Brahmagupta's ancient laws of sign for positives and negatives. And based on what he learned from the Indians, Al-Khwarizmi then wrote a book on algebra. And we get the word algebra from one of the words in his book title, and we get the word algorithm from Al-Khwarizmi. So from the Arabic world, India's mathematical foundations made their way to North Africa, where Leonardo Pisano, also known as Fibonacci, mastered them. And then Leonardo Pisano then documented India's mathematical foundations involving Brahmagupta's definition of zero as a number. And thus Europe came to understand Indian arithmetic. So the transmission of India's integer arithmetic went from India in the 7th century to the Arabic world in the 9th century, and then finally into Europe in the 13th century, which is how it developed into what we teach students today. What facts do we know? Zero is defined as any number subtracted from itself, like n minus n. Negative numbers are less than 0. -7 is less than -4. And every basic arithmetical operation on the integers is understood and has been for centuries. Euclid in his book Elements defined multiplication as repeated addition, and therefore AB is thus defined as A added to itself B times, and A to the power of B is thus defined as A into itself B times. So, if that is arithmetic, Jonathan J. Crabtree welcomes you on a journey from the death of arithmetic to the birth of Podometic. So, this is not just about the death of arithmetic, but it's about the rebirth of Indian mathematics, which is going to be launched in a year's time in India, with a series of free mathematics books made available to every child in India based on the correct foundations of mathematics that the world has not yet known. So what we know about arithmetic ain't so. Every previous fact is false. I gave you the conventional ideas of the broad brush history of mathematics, what happened from the travels from the 7th century India to the Western world and what we teach today. Every fact I had on those slides is false. And this presentation is to explore how India's mathematics came to be lost. So everyone is entitled to their own opinion, yet not to their own facts. So I'm like the prosecution for who murdered mathematics, and I have to make sure that I've got all of the evidence to prosecute my case. Somebody murdered mathematics, and I've been figuring out when, why, how, and who. So let's let arithmetic die and be reborn from zero. Now, extraordinary claims require extraordinary evidence. Tick. So, India's definition of zero never made it to either the ancient Arabic world or Europe. In the Arabic world, India's zero only came to exist as a placeholder, not as the power tool to solve simple problems like +3 minus +4, or -2 minus -4, or -4 minus +2. So, let's look at the evidence. Brahmagupta, you may be well familiar with him, famous astronomer and mathematician who wrote Brahmasputra Siddhanta in the year 628. So for this talk, Brahmagupta's laws of positives, negatives and zero have been freshly analysed, and you can see here that with the help of Sanskritists and mathematics professors both in India and also in North America, I've analysed line by line the Sanskrit of the laws of mathematics for the laws of sign for algebra written by Brahmagupta. Now, I'll continue on, but this is where I really found gold. I've been doing my research out of ancient Greek, Latin, Sanskrit, Arabic, Hebrew, French, German, Italian, Russian, Dutch, Czech, Spanish, Mandarin, about another 5 languages, but I finally struck gold with Brahmagupta. So, I'm moving on very quickly to Brahmagupta's 5 addition laws, Sankalana. So here, you're familiar with these. Positive plus positive is positive. Negative plus negative is negative. Positive plus negative is the difference between the positive and the negative. When positive and negative are equal, the sum is 0. That's a very powerful one, which has been missed. And positive plus 0 is positive. Negative plus 0 is negative. 0 plus 0 is 0. And positive plus 0 is positive. Negative plus 0 is negative. And 0 plus 0 is 0. And that's all bundled together in that Sanskrit verse or shloka. Why is Brahmagupta talking about adding 0 again and again and again if he didn't want us to decode how is this going to be useful in mathematics? We just teach 0 is the additive identity and we basically forget about it. But that's not necessarily the way to understand Hindu mathematics. So here on one slide are Brahmagupta's 5 addition laws, and boom, I get rid of all of those because only the first law was understood in the Arabic world. Because everything else is talking about a mix of positive and negative numbers. So let's move on to Al-Khwarizmi. I had seen that the Indians had set up 9 symbols in their universal system of numbering. So they made 9 symbols, which are these, 987654321, and every number is put together above 1. So Al-Khwarizmi didn't mention 0. 1 is the root of all number and is outside number. So Al-Khwarizmi didn't mention 0 and he didn't even accept that 1 was a number. Now, I'm not going to read the shaded out grey text. You can download this presentation and read that at your leisure. So let's move on to perhaps the next most influential Arabic mathematician, Al-Uqaydisi. And Al-Uqaydisi considered 0 a placeholder, but not a number. Why are the Hindi letters 9? So much for the 9 letters. 0, the aim is only to occupy the place. We multiply the letter by 0 to occupy the place and tell that there is a place and that it's empty. Now this man was really instrumental in the passage of Hindu mathematics into the Arabic world and then on, because he translated the system of the Goba dust boards, or writing the mathematics on dust and then erasing it step by step. He gave us the written form of the algorithms that we're more familiar with today. This man was very important in the passage of Hindu mathematics. It just happens that he didn't accept 0 as a number. So, 200 years after Brahmagupta, Al-Khwarizmi did not accept 1 as a number, 0 as a number, never. 300 years after Brahmagupta, Al-Uqaydisi, and I apologise for the wrong translations, I've never heard them actually spoken in the Arabic language. Al-Uqaydisi accepted India's 0 as a placeholder, yet not a number. Why? Al-Uqaydisi means the Euclidist. He was known for his skills in studying the Greek geometry of Euclid and translating it into Arabic. So around about 300 BCE, Euclid defined number as a multitude of units. So Euclid's definition of number came long before 0 and 1 were ever to be considered as numbers. Now, India defined 0 as the sum of opposing negative and positive numbers or quantities with the same multitude or magnitude. Now, if the Arabic and European writers in medieval times really understood India's 0, where are all the negative numbers in their writings? Brahmagupta defined 0 as the sum of equal negative and positive. So if the Arabic world and the Europeans in medieval time understood Indian maths, they would have written about all the negatives and positives that can sum to 0. But this is the situation, and I quote, "I have read a few dozen medieval Arabic books on arithmetic and algebra, and there is no hint of negative numbers in any of them. 0, too, was not regarded to be a number, but was merely the placeholder for an empty place in the representation of a number in Arabic, i.e. Indian, notation. All numbers in Arabic arithmetic were positive. No Arabic author, to my knowledge, ever even contemplated the existence of negative numbers." Now, if the Arabic world didn't contemplate negative numbers, you know what? That means we do not yet understand negative numbers, because it was largely through the Arabic world into North Africa, into Europe, that the transmission of India's mathematics heritage came to us. So, the maths myths that we know. India's definition of 0 as a number and integer arithmetic was not embraced by the Arabic world. Al-Khwarizmi wrote a book on Hindu integer arithmetic which did not feature Brahmagupta's ancient laws of sign for negatives and positives. Based on what he learned from the Indians, Al-Khwarizmi then wrote a book on algebra. No. When we go to school, we learn arithmetic first and then we learn algebra. And so people have put that back in the history of mathematics. They say Al-Khwarizmi wrote a book on arithmetic and then wrote a book on algebra, but no. He wrote his algebra text first, and then later on, when he started to learn about Indian mathematics, that's when he wrote his book on Hindu mathematics. So the Arabic algebra was not fully informed. And we think that the Arabic world carried India's mathematics along with the development of algebra. Only the very most basic arithmetic came for the journey. So, comparing Al-Khwarizmi's approach to Brahmagupta's, I quote, "Once again, Al-Khwarizmi differs from Brahmagupta, this time in not employing any abbreviation. Also, he avoids using negative numbers or a larger number subtracted from a smaller one, or from 0. Whereas Brahmagupta, like other Indian mathematicians before him, does not hesitate to make use of such negative numbers." It is difficult to imagine that Al-Khwarizmi, if he had read this chapter, i.e. chapter 18 of the Brahmagupta's Brahmasputa Siddhanta, it would be difficult to imagine that Al-Khwarizmi, if he had read this chapter, would not have been able to profit by it, even if to only shorten the presentation of his work. The style of the mathematical reasoning that is at work in Al-Khwarizmi's algebra has nothing to do with what we encounter in the work of his Indian predecessors. So, Brahmagupta had everything we need today. Basically 200 years later, Al-Khwarizmi didn't have 1 as a number. About 300 years plus later, Al-Khalisi only had 0 as a placeholder. So let's just move these gentlemen aside and look at Leonardo Pisano. So here we've got a quote that I made up. "I am Leonardo Pisano. I am the man most responsible for introducing India's arithmetic into Europe in the 13th century via my book Liber Abaci. As I got my Indian info from Arabic traders, I did not get to learn about India's definition of 0 as a number or the rules of positives and negatives. Whoops." So here I've got a map, and it's just for illustrative purposes only, but it tells a story of the transmission of 0 as a placeholder, but not as defined by Brahmagupta. So we start off in India, near Binmal, and it travels over to Baghdad, to the House of Wisdom of Al-Khwarizmi. Then it goes over to Northern Africa, where it finds its way to Leonardo Pisano, also known as Fibonacci. He takes it into Italy, and from Italy it then travels to England, and I'm skipping through hundreds of years of history there. And finally, one of the most influential people in the area of arithmetic is Robert Record. So those unaware, 0 was defined as the sum of equal positive and negative magnitudes of equal size, include Al-Khwarizmi, in Iraq in the 9th century, the traders of North Africa in the 12th century, Leonardo Pisano in Italy in the 13th century, and Robert Record in England in the 16th century. And for example, Robert Record's book on arithmetic was published for about 150 years. So that really was one of the most influential books that established how elementary mathematics was understood in England. I invented the sign equals and introduced the pre-existing sign plus to England. Yet I never knew about your zero definition, Mr. Brahmagupta, or laws of positives and negatives. So this cartoon is me. I've gained a little bit of weight. In 1478, the first book printed on maths, the Treviso Arithmetic, said numbers start at 2. So much for 0 and 1, which is all your computer needs. In the 16th century, England, people used Roman numerals and there was no Roman numeral for 0. Now the maths at the time in the Renaissance and after was based on ancient Greek maths which did not have 0, 1 or negative numbers. So the false idea that negative quantities are less than 0 rather than opposite in nature to positive quantities emerged in Michael Stifel's Arithmetica Integra of 1544 in a section titled De Sinis Additorum and Subtractorum and Numerus Absurdus. Basically, the signs of addition and subtraction and absurd numbers. So Michael Stifel said negative numbers were below 0, which is below nothing. Infra 0 id est infra nil, and negative numbers were absurd, numeri absurdi. Brahmagupta was an astronomer. He used positive quantities and negative quantities, and he had numbers to measure the opposing quantities because he was an astronomer and he was a scientist. And here we are almost 1,000 years after Aryabhata, and people are saying negative numbers are absurd, but they're essential to physics. To make sense of numbers that count or measure negative quantities, i.e. negative numbers, all we need to do is to drop the nonsense notation that negative quantities are less than 0. Then, negative numbers simply count or measure opposite quantities or forces which are always greater than 0. Perhaps you might recall Newton's third law, which states for every action there's an equal and opposite reaction. Bingo. Newton's laws of motion are consistent with Brahmagupta's laws of quantitative mathematics, which are also consistent with quantum physics. Think about it. 3 negative electrons and 3 positive protons, that should be positrons, are equal and opposite and cancel each other out to sum to 0. So as maths books got published in the English language, without 0 or 1 in algorithmic definitions or as numbers, they were exported to England's settlements and colonies, such as New England, which became America. So as the English language spread, so too did major misunderstandings of India's mathematical foundations. It's like there was a virus that was established and it got spread. England had the printing press, and the rest is unfortunately a negative history of the evolution of mathematics. So in the year 628, Brahmagupta gave solutions to equations we'd write today as x squared minus 92y squared equals 1 and ax squared plus bx plus c equals 0. However, the first person to say 1 was a number in the West was Simon Stevin in 1585, almost 1,000 years after Brahmagupta. The West is basically 1,000 years behind, and when they're starting to try and catch up, they've got everything wrong. Not everything, a lot. So where is 0 today? There's your typical keyboard, and if you look hard, you'll see it's a placeholder 0. 0 is still on the keyboard used as a placeholder, type 90, 90, type 20, 20. It belongs at the start because it's the origin of number and mathematics, but even our keyboard is giving up. So the mathematical foundations of India are true and correct and logical and consistent and very easy to understand. Children find no problems whatsoever with lessons to do with negative into negative or negative by negative. The foundations that emerged out of the British Empire through its period of colonisation around the world, those foundations were fatally flawed. So what I've done is I've assessed the world's pedagogical evolution from the time of Brahmagupta to now. If you look across the top row, I've just got examples of addition, and this is just, again, it's just integer arithmetic. The second row, it's got examples of subtraction. The third row's got examples of multiplication, and the fourth row has got examples of division. And what I've done, based on my analysis of Indian mathematics versus what's taught around the world now that came out of the West, is I've colour-coded all of the combinations of those four operations with both positive and negative. So if it's got a green colour, it's passed. It's adequate in our education systems around the world. If it's got a yellow cell, that means it's broken, it fails, it is fundamentally flawed and broken. And you can even see that there's one cell there where people don't even try to explain division of a positive number by a negative divisor. All they do for hundreds of years is they ignore the division and they convert it into a multiplication problem. Okay, so Podometic will soon replace arithmetic in a year's time. As I mentioned before, the plan is to give every child in India a set of free mathematics books, digital downloads, that will take this mathematics matrix with all of its problems in it, and everything will become green. Everything becomes so simple, 12-year-old children will be able to understand how integer arithmetic works to their mathematics teachers once they read these cartoon books. So, speaking of cartoons, hey kids, play with me and I'll make maths fun, fast and free to learn. From class 1 on, it all connects with the laws of physics as well. So, this is an example of some pages from the ebooks. There's Podo the puppy popping her head up, and she says, separate or all together, all my bricks and holes give me 0. So I'm Podo the puppy. All my maths adventures are being brought to life by AFX Animation in Kolkata. And there's the website address. So I've chosen a strategic partner in India for this project. This is an Indian project about the rebirth of mathematics from zero. Now, the hard work has been done. India can update its maths and prosper, or let this major maths education advantage pass by. I hope that doesn't happen. Because what we've got to do is we've really got to think. So here a long time ago I got some media coverage because, well, you know, people thought I was good at thinking and using my brain. There's the brain. We've got to start using all sides of the brain, all different modes of thinking as we educate our children. No more dry black and white textbooks. We're going to start with Podometic to involve imagination, colour, song, all sorts of things, and that's how the brain wants us to learn. So that's the creative side, the creation side, creativity. We've got to bring that into the mathematics education. So there's a sign that you're probably very familiar with. There's an image which is very, very upsetting. It's upsetting to me. I can't imagine how upsetting it is to the people of India to be going through such a period of drought as we enter an age of climate crisis. So big problems demand that we think bigger. Where is the courage? Is there going to be courage in India to fundamentally fix the huge problems that your country is in dire need of fixing? Well, that's an open question. But why is it so important that we fix mathematics? Because mathematics is the platform upon which all of the solutions of India's problems in the future are going to be built. So whether it's science, technology, engineering or medicine, it's mathematics which is going to help India overcome its problems and enter in a new golden age of prosperity and spirituality and happiness. So, I'm going to close off in a few slides. So I think I've actually done pretty well with my time. I've spoken more quickly than I usually do. So here's a poem. India's teachers so seldom know the trees of knowledge from seeds they sow. Past lives forgotten and the future a mystery. Making lives count, their deeds have made history. So make your life count with love as your measure, then kids will climb trees with views they will treasure. So thank you. And to those people who are watching on YouTube or on Facebook, if you care, please share. That's the web address. Prime Minister Narendra Modi, if you ever get to see this video presentation, I hope that you share it, that you embrace the vision of an Indian renaissance on Indian mathematics. I can assure you I will do whatever I can to work with your Ministry of Human Development and educational specialists. I'm here at your service, Mr. Modi, so please, 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 let's explore how we can work together. Thank you very much.
Thank you for a very stimulating lecture. One does accept that there is a lot of pedagogical innovation that we need, but sometimes I wonder whether the low scores of Indian students are more due to the language that they are taught in rather than the subject itself. I mean, what are your thoughts on that?
That's a really great question, and I'm going to give you a very quick example of how language is a huge problem in the language I'm speaking right now. When I go around, I ask people often, tell me, what's -7 minus -4? It's a very simple question. Most adults, I was never very good at mathematics. What do you think that person might answer over there to the question of what's -7 minus -4? And I think, -11? Now, in Australia, most adults will answer incorrectly. But if I change the way I phrase that person's child at age 10 will get the answer correct every single time. Now, the language is -7 minus -4, and people try and grasp the laws of mathematics. If it's negative subtracted, I've got to add it on. They have no understanding of what's going on. Here's the question I would ask to a child. If you've got 7 negatives and I take 4 negatives away, how many negatives have you got? And the child will say 3 negatives. Now, what have I done? I have fixed the syntactic structure of the mathematics, because -7 minus -7, the structure is adjective, adjective, verb, adjective, adjective. The way that we start to fix mathematics, Brahmagupta wrote about the laws of quantities that were negative and positive. So his was noun-based, right? It wasn't abstract. It was more like applied mathematics. So when we change it, we fix the syntactic structure, -7 becomes 7 negatives, minus 4 negatives. That then becomes adjective noun minus adjective noun, and that becomes just so obvious you wouldn't even think about it. So part of the process is I've looked at the way that everyone says that mathematics is a language. It's one of the common cliches about mathematics. And we all say that mathematics is a global language. Now, what I'm going to say is that sentences are to equations as expressions are to phrases. So we've got to make sure that when we communicate through language, that we give parts of speech that allow the brain to slot it into place with nouns and verbs and adjectives. And then children will understand it much more easily. Now, on the aspect of all the different languages, with the picture storybooks, it's basically visual learning. So Podo the puppy goes to the beach where it's ground level 0, right? She then has a square-sided bucket. She digs the hole, fills up the bucket, and makes a brick. So 0, ground level 0, has been split into one negative and one positive. Okay? So what we do is we teach through games that children understand, which is digging holes and making bricks or bumps, right? So then we play the games and everything becomes a metaphor for how physics works. And the language, you don't really need the language because children are just enjoying the cartoons. And I know this because I go down to Andhra Pradesh and all the children down there speak Telugu. You know, in Kolkata they speak Bangla. Over here they'll be Hindi. The cartoons speak to everyone. The important thing is that I need to work with India's teachers and maybe its education departments to run some courses for teachers so the teachers understand the pure simplicity of India's original mathematics before it got lost. So that's a great question about the language, but I don't see the language as a barrier. And my goal eventually is, if I can find some strategic partners, my goal is to have the series of mathematics books translated into all the languages that India needs. So it doesn't matter where these children are. So.
And the other question is, most of mathematics, I mean advanced mathematics today is highly symbolic, whereas all these ancient texts seems to have so much text, as it were. So when do you think this transition, I mean in your research, where do you find this transition from text to symbols, symbolic logic? Can you throw some light on that? Sure.
Well, I mean the ancient numerals were originally kind of like just tally marks, like scratch, scratch, scratch became 3. Most cultures originally used letters of the alphabet for their numerals. We think about the Hebrew, we think about the Roman numerals, and we think about the Arabic language. They just had letters of the alphabet as their numbers. It was actually the Hindu who came up with the idea of, rather than using letters of our language of the alphabet, let's create symbols. So it was actually the Indians who were the first to create mathematical symbols for digits, which is a massive achievement alongside all of the other massive achievements that India is responsible for. So in terms of the symbolic language, Brahmagupta was doing some abbreviations in his work. Al-Khwarizmi, when he wrote his algebra, it was pure text. It was just sentence after sentence after sentence after sentence. There was no abbreviation there. Now, I don't think that I think one of the problems, I might be getting a little bit too abstract, so you know, give me the thumbs down if I'm getting too abstract, but there are 2 types of arithmetic. In the ancient Greek, there's arithmos, which counts objects, like 3 horses, that's arithmos, okay? So the number is the adjective and it's counting or measuring nouns. But the other form of arithmetic is called arithmoi, or moi, and that is when the number is the noun. And all of the analysis is on pure number theory. That's originally what Greek arithmetic was all about. It was just purely number theory from people like Nicomachus of Gerasa and so on. So I think that the symbols are great, provided you understand what those symbols actually mean. So when I go into class 7 classrooms in India, I teach them about why 2 dashed numbers, the product is a positive number. And I say dashed number because teachers do not even understand that there are 2 dash symbols. There's one for subtraction and there's another for negative. And what I do is I make whether one is the verb or one is an adjective, I make it very clear. The adjective, negative and positive, they're superscript symbols. So when they're normal case, they're verbs. When those symbols are uppercase, they're adjectives. So we need to understand the symbols. And we need to understand what's going on with the relationships between the quantities, because mathematics is essentially about relationships between quantities, and all numbers do is count or measure quantities. Some of us would have driven here today, and there would have been a quantity of distance, and there would have been a quantity of time, and the relationship between those quantities gives us the average speed. So you don't even need those quantities to be the same sort when you're using mathematics with children. So look, it's a great question. Too much is about just memorizing symbols and equations. But what my research has shown is that around the world, we're usually focused on teaching the laws of mathematics and the various rules and the formulas. But what my research has shown is that many of the laws and rules that we teach in classrooms around the world, you know what they are? They're actually bug fixes and workarounds because the fundamentals are broken. So I'll give you a very quick example. 1 into 1, according to Euclid's definition of multiplication, equals 1 added to itself 1 time. But now that gives you 2. Now that definition of multiplication has been around since February 1570, and it took a 7-year-old boy to get stuck on that and decide to research it. No, India's 0 is missing in the definition of multiplication. 1 into 1 equals 1 added to 0 1 time. So there are so many major problems in the very simplest definitions that unless we had these workarounds and bug fixes, the bridges would fall down. Now the bridges don't fall down because we're learning all the rules and the laws, but if we had the correct foundations, you don't need to memorize how mathematics works because you just live and breathe it and understand it.
Thank you, Dr. Kaptri.
Not doctor, Mr.
Mr. Kaptri, you have made tremendous effort to raise the awake Indians. Thank you very much for that. Last year you were in Calcutta. I am from Calcutta. I'm just to request to you, in your main presentations, you have not mentioned minus into minus is equal to plus. That was in 1833, Brahmagupta's theorem. So if
I can explain that very quickly.
Minus into minus is equal to plus.
Yes.
That's 18, in your letter you have given, but in your main slide it was not there. So if you kindly...
Sure, okay. For a start, let's correct the syntactic structure. It's not minus into minus. It's not negative into negative. It's actually negative subtracted.
Negative subtracted.
That's it, right.
Okay.
Now, if you had mortgage payments that you had to pay every month of 5,000 rupees, pretty low, right? So you've got to pay that mortgage every month, right? Now, if I came along to you and I said, don't worry, I'm going to take away your debt every month, right? That's the same as me giving you money. A simple idea about, again, where the problem happened. So I'm looking for the clues on how and why India's mathematics didn't transition correctly. Now, one of the things about India is that you love ideas like infinity, and you love huge numbers.
Yes.
You love infinity, and you love 0. Now, but the Catholic Church didn't. The Catholic Church said only God was infinite, and 0 was the realm of the devil. So when you've got the clergymen, when you've got the ministers, who were the ones who were the gatekeepers of education in the Renaissance, they really didn't want to touch Hindu mathematics because they didn't want to be accused of blasphemy, because the only educated people were the people in the church. So when only God is infinite and the Indians are talking about infinity, oh, that's not a good idea. And they're talking about 0, well, that's the realm of the devil. So you also had religious overtones in the transmission from one culture to another that meant that people just instinctively shoved it away because they thought, you know, something with religion was not quite right about ideas like 0 and infinity. And yet, as we know, they are just some of the most beautiful ideas that there are. But originally, the Catholic Church said it was a big no-no.
So these are we should come out from the mentality of slavery and put things right track, what India has done.
Now, what I'm going to say might be controversial, as if saying that basically all of the foundations of maths are broken. That's pretty controversial as well. But with the PISA international testing, India might want to think long and hard about, is it really necessary to try and compete with the ideas in Western mathematics, when now I'm demonstrating that so many of those ideas are not the correct ideas. So it may well be that India might return to the PISA testing. It hasn't been involved since around about 2009 plus is the last survey that India participated in. But I'm just suggesting that maybe the Indians should not worry about how Indian students do against the rest of the world when it comes to elementary mathematics. Maybe we should here focus on India's mathematics, which is going to be completely consistent with engineering and the laws of physics, and be so much easier for teachers to explain. So there are some policy questions that need to be addressed. One of the questions I have from teachers when I visit schools is they love the mathematics that I'm showing them, and there's heaps of really simple mathematical ideas that all the children just completely understand, and otherwise the children will be totally confused. Now, is India going to keep trying to teach Western mathematics to its children? Why not at least explore ancient Indian ideas? And I'm here to help develop a curriculum for India for its primary level classes if India wants to take on board this offer that I have. So I'm suggesting, rather than chasing the West, and we know that at the moment that hasn't worked, because out of 74 countries, India only beat Kyrgyzstan. So doing more of the same isn't going to help. As I've got in that slideshow, big problems need big thinking. And I just really hope that India is bold and brave and can say, well, we're going to at least explore side by side the Western mathematics pedagogies that everyone just follows, regardless of how broken they are. And I've come across all the research on why they're broken, and at least start to do some pilot tests just to compare to see what sort of mathematics education the children prefer. Last year, I was down at Andhra Pradesh at some Sri Prakash synergy schools down there from students. And I would say to them, at the start, the mathematics that I'm going to share with you is going to be different to the mathematics that your teacher has been teaching you. And I want you to just understand that the mathematics that your teacher has been teaching you over the previous years is Western mathematics. But what I'm here is to just share with you some ideas about Indian mathematics. Now, after that lecture, and I go into a lot of detail, I'll usually ask the children, so which one do you like better? Do you like the Western mathematics or do you like the Indian mathematics? And they're all calling out, Indian, Indian, Indian. The children want it. They love it. And if you want children to be hungry for mathematics and for study, then give them some nutritious content, which is Indian mathematical ideas. So, are there any other questions? Yes.
Okay, so you would agree that at a certain level, standard 6, 7 or 8, mathematics suddenly becomes complicated. I have studied from a central board, CBSE, and I'm talking about that. And I believe that more or less all the boards are same. So at that stage, half of the students start shying away from mathematics. Mm-hmm. In a parallel universe, they might have pursued mathematics had it been simpler.
Yes.
So if you agree to it, my question is it the same across the world, or is it special to India, or, you know,
no, it's pretty much the same all around the world.
So we lose the whole, you know, suppose we start with 100 students who would have been interested in
yes.
mathematics. We come down to maybe 2 or 3 at the end of the education line.
That's pretty much the consistent pattern. You've got some countries where the children are basically like prisoners to study, which is not really a holistic way of bringing out the knowledge in the child. It should be a joy for the child. But also, I've done lots of fun things in higher level mathematics that people haven't seen before. And very often these come to me in my dreams. I sleep on the floor usually, and I choose to sleep on the floor because it's uncomfortable. So 2 or 3 times a night I'll wake up because I'm uncomfortable, and that's when I will talk into my dictaphone about the mathematics that I've been dreaming about. Because I found that if I ever just open my eyes or turn on a light, the dreams disappear. Now, there are so many beautiful things in geometry that children are not exposed to at all. And yet you give them some simple ideas with geometry and the children will want to do more. I've done some really cool things with a circle, for example. With a simple model of a circle will do multiplication on the real number system. Draw a circle and it gives you the answer. If you want to do division on the real number system, have your 3 points, the unit, the dividend, the divisor, and bang, a circle will give you the answer. Now, I shared this sort of geometry with some of the top people in England at the cliched top universities over there. They'd never seen anything like this. And yet what I do is I say, whoa, if only Descartes had known about this. And I've got some, in the download, in the slideshow, I can give you some, in fact, it's not in this slideshow, but in lots of the slideshows I've got, I say, what would happen if Brahmagupta had met René Descartes? Boy, there's a real mind explosion, and suddenly all sorts of really cool things happen that people haven't seen before. Now, just a couple of weeks ago, I had another lovely little insight, and that is that mathematics would have evolved totally differently if the ancient Egyptians ate fish. That sounds a bit weird. Let me explain. The idea of where geometry came from goes back to thousands and thousands of years ago in the days of the Egyptians building their pyramids and the flooding of the Nile. You might have heard this story, that Thales went to Egypt and learnt a lot about geometry. Why? Because every time the Nile River flooded, the farmers, they would lose land. And the farmers had to pay tax and rent to the pharaoh based on how much land they had. So the mathematics that started in ancient Egypt was all about land measurement. So guess what? That's geometry. Geo means earth, metry means measurement. Okay? So right today, the geometry we teach is based on the fact that the ancient Egyptians were farmers. Now, what if the ancient Egyptians were fishermen? And what if they needed to cast their nets onto the Nile River? For them, they might have developed hydrometry. Okay, instead of geometry, it would have been hydrometry. So then I got thinking, okay, what if they're both there? And every time the Nile floods, that's positive for the fishermen because they've got more surface area to cast their nets. But it's negative for the farmers because they've got less land to plant their crops. This is physics in action. As the positive increases, the negative recedes. So the farmers would say every time the Nile dropped, that would be positive for them, but it would be negative for the fishermen. So I've just written a paper that hopefully will be published later on in a maths conference I'm attending. I've got 2 more maths conferences to attend this December. And I talk about the principle of positive and negative quantities on what I've called the Brahmaguptan plane. And all of a sudden, I've introduced a whole way of thinking and talking about negative geometry and positive geometry that the world's never seen. Now, in my research, these are really simple diagrams that children will understand, but they suddenly make a whole lot of algebra really simple. And I've looked at the algebra of Diophantus through to people like Cardano and how they struggled with the laws of sine and trying to come up with a geometric model. Oh, if they only knew that there were fishermen as well as farmers, they could have, boom, had completing the square based on both positive and negative areas. So there are so many new ideas that can maybe augment the existing lessons that children struggle with. There's just a whole lot of fun to be had in those more advanced middle school years.
And so I have a question. Are these your innovations, or are these
Sorry?
learning? Are these your innovations with the circle and
Yes.
or are they? Did you learn something from Brahmagupta?
Well, look,
texts?
what's happened is, starting in 1983, when I made that promise to fix maths, I've done a lot of, I've explored a lot of wrong areas. You make a lot of wrong decisions when you're trying to explore mathematics and how it works. But the ideas that I've been producing are original mathematics, original ideas, but I'm informed by hundreds of past mathematicians. So when I did that diagram on how to use a circle to do multiplication and division on the real numbers, that was based on Van Schooten's work that René Descartes stole. So René Descartes, whoa, the genius, well, he kind of basically stole his work from what I can understand from Van Schooten. There was a diagram in Van Schooten that I thought, whoa, and then I came up with this idea. Now then what I also do is then I create GeoGebra applets, okay? So then children can play with these models interactively through GeoGebra, and then they just see it happen with their ideas. So it's no longer just the realm of static geometry, but you can actually play with it nowadays. So look, I have never pursued academia. A lot of people think I'm a professor because I write articles as if I was a professor. But no, I've just done a whole lot of thinking. I've done a whole lot of reading, and I've done a whole lot of experimentation. And the metaphor that I've got is, when I began, it was like mathematics was like a jigsaw puzzle box. It had 10,000 pieces in it. And it didn't have a lid on the jigsaw puzzle box. So it wasn't easy to place where the pieces of the puzzle belong. Also, in that 10,000 piece jigsaw puzzle box, a whole lot of pieces were missing and a whole lot of wrong pieces were in there. So slowly, bit by bit, I've been throwing out ideas, bringing new ideas, and now I've assembled the picture of mathematics and its structure from Brahmagupta right now through consistent to the laws of physics, and it's just beautiful and consistent. What children learn in class 1 stays with them right into university. At the moment, we keep changing the story. We say, you can't take a larger number away from a smaller number. But later you can. Oh, you can't take a square root of a negative number. It's impossible. Oh, but later on you can. So let's stop lying to children and have one consistent story that starts here and is completely intuitive and goes all the way through.
What I conclude is that it's not the mathematics part of it, but it is the teaching methodology which is hopeless. I have never seen a hopeless student, but I keep seeing, I saw it in my own student days, I've seen it in my son's school days, and I keep on seeing bad teachers. The way they learned, they repeat it when they become teachers. So it is the methodology which I can catch from the examples that you have given. It is the methodology which makes a child attracted to mathematics and not, be afraid of it.
When I was a little boy, before I went to school, I loved maths. I loved counting things. I loved playing with my blocks and building things and so on. That's mathematics, that's geometry, and that's counting, and that's measurement. And very often, that's the right hemisphere of your brain. And typically what happens is when children go into the production line that we call school, the right side of the brain is shut down and it all switches onto the left brain. It's all symbolic. It's all about abstract stuff. And where did the fun bit go? So I basically, for the last, 3 decades plus, my goal has been to uncover a way of teaching mathematics that children in the primary classes would love, because that's what I didn't have as a child. So why do I have cartoons? Because as a child, I liked cartoons. Why are things filled with colour, and why do I have games? Because I liked that as a child. I had a peer-reviewed paper published in Hungary a couple of years ago, and I don't think there's ever in the history of mathematics been a paper like it. And this paper, which was filled with scholarly material, was a 4-act comedy. And the people in the 4-act comedy play were all children in class 2 and 3, but those children were Brahmagupta, Euclid, Isaac Newton, René Descartes, and they were talking about the stuff that their teacher had said in the maths class. And they were bouncing around ideas with each other. And it's funny, it's got jokes in it, but it's all absolutely foundational mathematical ideas. And it was a 4-act comedy play, and then as if that's not enough, it also had sheet music in it, with all of the music to sing a song. Well, it's freely downloadable. I want to give this to everyone. But like, that's the approach I've got. Maths, like, the transmission of Indian mathematics was a verbal tradition. That's why it's all done in verse and shlokas, right? Children love to sing. So, you know, multiplying can be fun, you see. Do to A as 1 made B. Division, you'll see, is lots of fun. Do to A as B made 1. Multiplying can be fun, you see. Do to A as 1 made B. So these are songs, and children will love that. And then that's bang. That's the mnemonic tool that gives them how to do multiplication and division on the real number system. Okay? So it's got to be joyous. And if you can have a child discover for himself or herself something really exciting, I tell you what, discovery is addictive. And that's what I have found in my life. About 10 years ago, I quit my career as an executive. I sold my house, and pretty much for the last 10 years, I've just been working on this project. Nothing else except doing odd jobs here to pay the rent. So the reason I'm doing this is I'm addicted to discovery. And I am, like last week with the idea of the fishermen and the farmers and negative geometries and so on, boy, my head exploded with joy when I had that simple idea. And so often there's a cliche that history is written by the victors, the people in power, and the other cultures, the oppressed, their mathematics, their science, that's not documented. So, look, I just believe that there's a whole lot of love and joy and happiness to be had by embracing more of the Hindu tradition of the true mathematical foundations. And what I'm doing is I'm attempting to deliver it in a fun, joyous way, because it just makes me happy. I want other people to be happy with it.